Hello friends, in this video I will do a problem on motion under gravity. So this problem is called up and down motion in free fall. So the problem says you throw a ball vertically upward from the roof of a tall building. The ball lifts your hand at a point with an upward speed of 15 meters per second. The ball is then in free fall. On its way back down, it just misses the railing. Then we have to find the first part of the problem says the ball's position and velocity at t is equals to 1 second and 4 seconds after leaving your hand. So we have to find ball position and velocity at t is equals to 1 second and t is equals to 4 seconds after this ball leaves your hand. So basically this is the ball here we have, and this is the tall building, and this ball is thrown vertically upward. So this will go in a straight line in the vertical direction. Basically there are many possibilities. You can throw this ball like this or like this or like this or like this. If you throw any one of the direction or any one of the orientation as shown, this ball will follow a parabolic path, something like this. And this is an example of projectile. In that case, you will have two direction motion, x as well as y, and then you have to basically solve for x as well as y. But in this case, problem is relatively simple, and this is only one direction motion. So ball is thrown vertically. So what will happen? The ball will go up in a straight line and it will follow the same straight line and it will come down to the ground. So if I show the same thing, I can show this ball is going up. So it will go up, and at to certain point of time it will have zero velocity in the vertical direction, and then the ball will start coming down. So this ball is coming down. So this is the path of the ball. So this is going up and then this is coming in the downward direction. So this is the path of the ball. Basically I am showing here two lines, but in fact there will be only one line. So the ball will go in the same path and it will fall in the same path. So there is only one straight line. Just to illustrate, I have shown here two straight line. The path that I have shown separated is exactly same path in actual situation. And the question says this ball is under free fall. So this is under free fall. So when I say free fall, what does that mean? This means acceleration is due to gravity. So this means this ball this ball will experience an acceleration, and that is value of z. So this is acceleration due to gravity. So if you see, let's say initial velocity that is given in this problem, so u by that is 15 meter per second. So this ball has been thrown at a speed of 15 meter per second. As ball will go up, its velocity will decrease. Why? Because earth is trying to pull this ball. So gravity is acting in the downward direction. So its velocity will reduce. So ball will slow down, and eventually at the top point this ball will come to the rest. And then the ball will have downward velocity. So downward velocity will start increasing. Why? Because the ground is pulling this ball. So the velocity in the downward direction will increase, and finally this ball will come to the ground. Now we have to find position and velocity of this ball at different point of time. So to solve this problem, first we have to identify an axis, and since this is a one-dimensional problem, we need to have only one axis. So let us define y-axis, because this is a vertical motion, so we can define a y-axis. And generally the origin is taken as the point from where the object starts the motion from rest. So this is the point from where the ball starts the motion. So we will take this axis, that is the vertical axis, is the y-axis. So this is my y-axis. This means positive direction of the y-axis is in the upward direction. What will be the gravity? Gravity is acting in the downward direction. So gravity is basically negative. So I can say initial speed, that is u by, is equals to 15 meter per second, and this is positive. Now what about a by, that is acceleration in the y direction. Acceleration is acting downward, so this is minus z, that is minus 9.8 meter per second square. Now once I know initial velocity and acceleration, I can apply formula for constant acceleration to calculate position or y of the ball, so distance of the ball from the origin. So if you remember, we have a formula something like this: s is equals to ut plus half at square, and this formula can be used to calculate distance of the ball from the origin. So let's say if I write the same expression for y axis, we can write y is equals to u by t plus half, and acceleration is a by in this case, and t square. So let us plug this value. So y is equals to initial velocity is 15 meter per second times t plus half, acceleration is nothing but 9.8 with a negative sign, meter per second square, and times t square. So y will be 15 meter per second times t minus 4.9 meter per second square, and this is t square. So this is the expression for y. So if I plug the value of t in this expression, I can calculate y. Now similarly, I have to also calculate velocity of this ball at different point of time. So you may remember formula v is equals to u plus at. And if I write this formula for y direction, I can write v by is equals to u by plus a by times t. So I can write v by is equals to u by is given, that is 15 meter per second, plus a by is nothing but minus 9.8 meter per second square, and this multiplied by time. So now I can basically calculate by, that is position, and v by, that is velocity of the ball at different point of time. Let us calculate these two at t is equals to 1 second. So if you calculate this for t is equals to 1 second, that is you have to put t is equals to 1 here and t is equals to 1 here. You will find y is equals to 10.1 meter. And similarly, v by will be, that is you put t is equals to 1 here, then you will find vy is equals to 5.2 meter per second. So you see, in this case, basically y and vy both is positive. So this is possible only when the ball is going in the upward direction. So what is y? Y is 10.1 meter. So I have started from here. So ball is somewhere here. So t equals to 1 second, ball is somewhere here. That is distance of 10.1 meter, and the velocity is in the upward direction. So this is the position of the ball, and this is the velocity of the ball. Now we can also calculate at t is equals to 4 seconds. What I have to do, I have to simply plug the value of t in this expression, that is equation 1 and equation 2. So if you plug this value, we will find y is equals to negative 18.4 meter. And vy is equals to negative 24.2 meter per second. Now you see, in this case, both the y coordinate as well as velocity, both are negative. This means ball is in the returning journey. This means ball has basically reached to the highest point, and then this is coming down. And how much down? This is 18.4 meter. So from 0, so this is my origin, so this is origin line. So from here, this ball is somewhere here, and this distance is 18.4 meter, and the velocity of the ball is in the downward direction, and the magnitude of velocity is 24.2 meter per second, and this ball is going in the downward direction. So this is the situation at t is equals to 4 seconds, and this was the situation at t is equals to 1 second. One more important point in this case, you can see that Vy, this value has increased significantly. Initial velocity was 15 meter per second. Now this value is 24 meter per second. So 24.2 meter per second. Why this happened? Because of the gravity. So gravity is basically pulling this ball in the downward direction and increasing the speed of the ball, and that's why the speed of the ball has increased, and this is now 24.2 meter per second. Now let us do the second part of the problem. So this part says we have to find the ball's velocity when it is 5 meter above the railing. That is above the railing. So this is my origin. So this is the railing point. Above the railing, this means somewhere here 5 meter. This means y is equals to plus 5 meter. And what we have to find? We have to find velocity, that is Vy. So distance is given and we have to find velocity. Of course, acceleration is also known to me, and in this case acceleration a by is equals to minus g. So which formula you will use? You will use v square is equals to u square plus 2as. So this is a formula for constant acceleration, kinematical formula. I can write same formula for bidirection, and in that case I will write v by a square is equals to u by a square plus 2a by, and distance s will become distance in the y direction. So we can write v by a square is equals to u by is known to me, that is 15 meter per second, a square plus 2, and acceleration is minus 9.8 meter per second a square, and this multiplied by is known, that is 5 meter. So from here you can calculate v by, and this if you calculate, this will come plus minus 11.3 meter per second. So you see there are two possible velocity, one with a positive sign, another with a negative sign. What does this mean? This means one velocity is in the upward direction, the positive one, and negative one is in the downward direction. So this means the distance 5 meter is reached when there are two possibilities. Let's try to see this. So this is the path of this ball. If you remember, this is the path of this ball. Let's say this height is 5 meter. So when the ball is going up, it will have a distance of 5 meter from the origin, and in that case velocity will be 11.3 meter per second. And this ball will come to the 5 meter once again, that is the returning journey. So this is downward journey. At this point of time again, this ball has a height of 5 meter. So this time this has a velocity in the downward direction, and the magnitude of velocity will be same, that is 11.3 meter per second. Only thing is this velocity is acting in the downward direction. So velocity direction has reversed, but the magnitude of velocity is same for a given y. In this case y is equals to 5 meter. And the third part of the problem says we have to find the maximum height reached by the ball. So basically this ball is going in the upward direction, and then it will come to maximum height, and then this ball will start going in the downward direction. So we have to find this height, that is the maximum y. What is the maximum y that this ball can take? How we will find this? So important point, when we have maximum y, this means y velocity is no longer more, otherwise it can go further. So this means velocity in the y direction is 0. So we will use this fact, that is v by is equals to 0, and then from there I can calculate what is the maximum height that this ball can go. So we will use the same formula, that is v square is equals to u square plus 2as, Now if I write for the by motion, I can write v by a square is equals to u by a square plus 2, and acceleration in this case is minus g, and s is nothing but by max. So what will be v by? V by will be 0 as I said, and u by is nothing but 15 meter per second, and this is square plus 2 times minus 9.8 meter per second the square, and this multiplied by max. So from here I can calculate by max. So by max will be, this is equals to 11.5 meter. So basically ball can go maximum up to a height of 11.5 meter. And the last part of the problem says, find the ball's acceleration when this is at its maximum height. So when we have by is equals to by max, that we have calculated just, so this value is 11.5 meter. So at that point of time, what is the ball acceleration? So this is generally a misconception. A student often think that at highest point, so when the ball is at highest point, the v by is 0 as well as acceleration in the by direction is also 0. This is not the case. A by is not 0 when ball is the highest position. Acceleration in the by direction is always acceleration due to gravity. So this is always fixed. A by is equals to z with a negative sign. This means A by is always acting in the downward direction, whether the ball is at rest or whether ball is at the maximum height or somewhere in the middle of the path. A by the acceleration of the ball will always be equal to minus g. So do not have this confusion in the mind whenever you are doing some problem related to motion under gravity. Now we can try to plot the velocity and position of this ball with time. So we calculated the expression. So let us try to plot by and Vy as a function of time. So if you remember, we calculated or we determined the expression for by. So what was the expression? By is equals to 15 meter per second. This expression we calculated in the first part, times t minus 4.9 meter per second square, and this multiplied by t square. So this was the expression for y as a function of time. Now I want to plot this function. How we can plot? So let us say this is my y-axis and this is my x-axis. So on the x-axis I have time, on the y-axis we have distance from the origin of the ball. Now this is an equation of parabola. Basically you can plot by taking different value of t and you can calculate different values of y. So what you have to do? You have to plug the values of t and you have to calculate the values of y, and then you could plot the graph. So for different t, what is the value that is coming? For example, if you put t is equals to 0, y is equals to 0. So t equals to 0, y is equals to 0. And then you can also find other time what is the value of y, and then you can plot this graph. Now since I know that this is a graph of parabola, so this graph will be something like this, because this is a graph of parabola, and where this will end and this will end at the ground. This means this is the height, that is the height of the building, that is h. This is the graph of the parabola, and what is this height? This is the maximum height of the ball, that is by max, that we calculated in the first part. What was the value? That was 11.5 meter. So this is nothing but 11.5 meter. Similarly, I can plot velocity as a function of time. So if you remember, Vy is equals to 15 meter per second. This expression we calculated in first part of the problem, minus 9.8 meter per second square, and then times. So this was the expression that we calculated in part A. Now can you tell me what is this expression? So this is the equation of So this is the equation of a straight line. So this is the equation of a straight line. So let us plot this. On the y-axis we have v by, and on the x-axis I have time. Now when you put t is equals to 0, what is v by? When t is equals to 0, Vy is nothing but 15 meter per second. Now this is a straight line, and what is the slope? Slope is negative. So this is a straight line and slope is negative, and this line is passing through this point. Then this means I have this graph. So this is the graph of Vy versus t. Basically you can find this time. What is this time? At this point of time Vy is equals to 0. So if you plug in this expression Vy is equals to 0, you can find time. So this is equals to 15 meter per second minus 9.8 meter per second square, and this multiplied by time. So from there you can calculate time, that is 15 divided by 9.8 second. So this time is nothing but t naught. Let's call t naught is equals to 15 divided by 9.8 second, and that is equals to 1.53 second. So this concludes this problem. So in this problem we have seen, if you throw a ball vertically up, how you can calculate the different point of time, what is the position of the ball, what is the velocity of the ball. And you can also calculate for a given body what is the velocity. In that case we have seen there are two possibilities, one for the upward journey and another for the downward journey. And finally we also plotted body versus time and velocity versus time. In one case the graph is parabolic, in another case this graph is a straight line. I hope you enjoyed this video, and if you like this video, please share with your friends, and I will see you in the next video. For the time being, thank you, bye, take care.